Hi students, welcome to Max Point of View. Today we are going to understand the concept of deviation, dispersion and spectrum. This is part A of the main chapter, spectrum. So here we are going to understand the concept completely in depth so that it will be very useful whenever we are solving the theory solution. Few things which we have learnt in refraction through a plane surface are definitely going to be useful. Very simple basics are going to be useful here. So if you have that knowledge, then this is definitely going to be a very easy session, and based on this whole complete spectrum, part A, part B and part C, maximum of 4 to 5 marks you can expect in the board exam. So without wasting any time, we'll start with the concept. As the name suggests, we have to learn the meaning of deviation, dispersion and spectrum. No need to by heart it. I will teach you the proper method to understand. See, deviation. Deviation means you should never by heart any word in physics. You need to understand. Then only you will get the complete concept. Listen. If you take an example of prism, okay, if this is the incident ray, do you think the refracted ray will be in the straight line of the incident ray? No, right? There will be some refraction, correct? Again there will be a refraction. See, like this. If you take glass slab or rectangular glass slab or square glass slab, okay, if the light is incidented like this, do you think the refracted ray will extend in the same direction? No, right? There will be a change in path, correct? There will be a change in path. This change in angle we call it as deviation. This change in angle we call it as deviation. So this is the exact definition of deviation. And you know, in the main board exam, okay, they are not going to ask you much definitions. For 80 marks only, 2 to 3 definitions they will ask. So if you know the keywords, you can aramse get the complete marks. Now we'll talk about dispersion. See, dispersion is nothing but the process of splitting of light. So the process of splitting of white light into its constituent colors once it is passed through a prism. That means very simple. If a white light is passed, okay, not monochromatic, keep this in mind. See, if a monochromatic light is passed through a prism, there will be no dispersion. What do you mean by dispersion? Splitting of colors. Okay, assume a white color has many colors. Okay, when it is entered through a prism, it will split into different colors. This process is known as dispersion. Okay, this process is known as dispersion. Now if a monochromatic, what do you mean by monochromatic? Single color. If a single color is passed through a prism, there will be no splitting of light, there will be no dispersion. Okay, so white light is a polychromatic in nature. That means it has many colors inside it. When it is passed through prism, it will split into many colors. This splitting process is considered as dispersion. Okay, now so it splits into different colors. Again there will be a refraction. Don't worry about the number of lines or number of colors. We need to understand what is dispersion. Next, the final one is spectrum. See, after splitting, okay, after it gets splitted, after dispersion, okay, these band of colors togetherly we call it as spectrum. See, these band of colors togetherly we call it as spectrum. See, one more time the complete 3 definitions. Deviation means whenever light is incidented, okay, it changes its angle after refraction, right? This is called as deviation. Now we'll talk about dispersion. If a light is given, okay, polychromatic light, not monochromatic, keep this in mind. Monochromatic means single color, it cannot split into other colors, so there will be no dispersion in monochromatic. Now anyhow, white light we are talking about, it's a polychromatic. Whenever polychromatic light or white light is incidented in a prism, so it splits into different colors. This process is known as dispersion. Whenever we have different colors, these band of colors after dispersion, okay, we call it as spectrum. So these are the definitions. Now we'll talk about the factors which affects the deviation. So first we'll learn everything about deviation, then we'll go for dispersion, after that spectrum. Okay, now so anyhow the definitions of all the 3 is done. Now we are going to learn the factors which affects the deviation, okay, in a prism. See, first, angle of incidence. See, these are the factors. In the exam they may ask you any one or two, so they will not cross more than two. Okay, because most of the questions in physics will be of 1 mark or 2 mark. So any one factor or two factors they will ask you. They can ask you what are the factors, or they may ask you how it is affecting angle of deviation. You have to know both the things. You have to be in a safer side. Listen, these are the factors, okay, which will affect deviation. How angle of incidence will affect angle of deviation? Very simple. As the angle of incidence increases, angle of deviation decreases first and reaches the minimum deviation and again increases. So if you remember this graph, angle of deviation we learnt. Okay, see, as the angle of incidence, this is angle of incidence, increases, deviation first decreases, reaches the minimum deviation point, okay, here, and again it starts increasing. So we cannot say angle of incidence is directly proportional to angle of deviation, because it once it decreases, again it increases. So there is no direct relationship between angle of incidence and deviation. So it keeps on increasing and decreasing. Next, first decreases. See, as the angle of incidence is increasing, deviation first decreases, then starts increasing. This you should know. Next, material or refractive index. Refractive index is directly proportional to deviation. See, this is the symbol of deviation. If you write like this becomes angle of deviation, but in the exam never ever use these symbols. Okay, this one also you have to write it in full form. Material or refractive index is directly proportional to angle of deviation. In the sentence form you have to write it. You should not use any one of these symbols in the exam. Next, angle of prism. Angle of prism is considered as A. Okay, if you take a prism like this angle we considered as angle of prism. Okay, so that is directly proportional to angle of deviation. Angle of deviation. Next, color or wavelength. We know color and refractive index are inversely proportional, correct? Color and refractive index are inversely proportional. You can take it as color or wavelength, anything is fine. You don't have to worry about it. Whenever I talk about wavelength, that means we are talking about color. If I am talking about color, means we are talking about wavelength. You have to think like that. Next, color or wavelength are inversely proportional to refractive index, so they are also inversely proportional to angle of deviation. So if the color, okay, if the wavelength is more, deviation will be less. What do you mean by that? Very simple example I'll take. See, if a white light is incidented, we can see like this, correct? Different colors. So which will have more deviation and which will have less deviation, that is very much important. See here, if the color is okay, if a white light is incidented, it will split into different colors. That process is called as dispersion. The band of colors we call it as spectrum. Now here, deviation and wavelength, which has more wavelength out of Vibgayar. In Vibgayar order, if you take, red as the maximum wavelength. If the wavelength is more, deviation should be less. What do you mean by deviation? Deviation means change in angle. See, light is given here, which has taken more turn. More turn means more deviation. So which has out of all these colors, which has taken more turn out of Vibgayar, we write it has taken huge turn. So that means it has more deviation and it has very less wavelength. That is how we can easily prove it. Okay, so if wavelength is more, deviation will be less, because these two are inversely proportional. See, red has maximum wavelength, correct? So if it has maximum wavelength, it should have minimum deviation. See the difference in angle. Incident ray, it has only, there is a small change in angle, but think about the violet. Okay, it has taken huge turn, so it has huge angle of deviation and it has very less wavelength. Okay, now these are the factors and how it is affecting it. Now we'll talk about this white color in air or vacuum. See, this white color will not disperse, okay, will not get dispersed in the air or vacuum. So that means all the colors will travel at the same speed in air or vacuum. Actually, it is only possible in vacuum. Okay, it is only possible in vacuum. Not only the colors, all the radiations which we are talking about, okay, like gamma rays, x-rays, which we are going to learn in part B of the same chapter, spectrum. Okay, all the colors and all the radiations will travel with the same speed in vacuum. Keep this in mind. All will travel with the same speed. Which color, red or blue, okay, or red or violet, will be faster in vacuum. Both speed will be same. If they are asking you to compare the speed, it will be 1:1, okay, because they have same speed in vacuum, only in vacuum. Okay, now white color in air or vacuum. When it comes to white color, so it is a polychromatic, correct? Polychromatic. Here this light, okay, which is there in the air or vacuum, it will not get splitted. It will not get splitted because the medium, okay, the medium we assume it as negligible medium. But when the same white light is incident in the prism, it will get splitted into many colors. That process we call it as dispersion. After it gets splitted, the different colors, the band of colors, we call it as spectrum. Next, subjective nature of light. Okay, this is very much important. What do you mean by subjective nature or subjective property? Very simple. If a property, okay, if you take anything, if it is different for different people, okay, I'll give you an example. Assume I'm standing here, okay, there is one more person standing next to me, and there is a sound coming from in opposite direction. Okay, we are both in same distance to that sound, correct? But we hear in a different loudness, correct? The loudness differ from people to people because completely it is based on our sensitivity of the hearing, correct? So it is different for different people. Subjective nature means that is the same thing. Okay, subjective nature means the property which will be different for different people. Okay, so we are standing here only, the sound is coming from one source, we are standing in the same distance, but the loudness is different for different people. So whatever, okay, it is different for different people, even though it is the same source. Okay, assume there is a painting on a wall, I see is a different color and someone sees it as a different color. So even though the painting is same, it is different for different people. So what is different? Color is different. So color is the subjective nature of light. Keep this in mind. What is the subjective nature of light? That is color. Okay, why? Because it is different for different people. Next, most deviated color and least deviated color. See, most deviation means most turn after refraction. Okay, after refraction it has to take huge turn. Okay, if you think about it here, okay, this is the incident ray. Okay, these are the different colors. Which has taken more turn? Violet, correct? See, it has taken more turn, so that means violet is most deviated, violet is most. Least deviated is red. See, red has maximum wavelength. Okay, it has more speed, so more wavelength, more speed, but it is least deviated. Keep this in mind. Violet, okay, it has less wavelength, it has less speed compared to red, but it has it is the most deviated color. Okay, keep this in mind. Next, 1 angstrom. See, above a, if you write a degree symbol, that becomes angstrom. Okay, angstrom. So here 1 angstrom is equal to 10 power minus 10 meter, and we know 1 nanometer is equal to 10 power minus 9 meter. Therefore, how we can relate these two? 10 angstrom is equal to 1 nanometer. These are the relations. See, if you know this much, that means you have learned everything about deviation. Now we'll talk about dispersion. See, we have learned the meaning, and this diagram also we have learned. Again, I'm going to teach you just to make your knowledge stronger. Listen. This is the incident ray, white color. See, you should not take monochromatic. Monochromatic means what? Single color. If a single color monochromatic light is incidented, there will be a refraction and there is one more refraction, correct? But there will be no dispersion. Why? Because it is monochromatic. It doesn't have any colors. White light, if you incident white light here, okay, there will be different colors in white light. So there will be a dispersion. And see, we need to learn some basics about refraction in prism also. Listen, so dispersion, we have learned the meaning. The process of splitting of white light by a prism into its constituent colors. Okay, this process is known as dispersion. Now what happens? See, when a white light is incidented, okay, see, this is red and this is violet. Now listen, see what things you need to understand. Dispersion is nothing but splitting of colors into its constituent colors. Okay, now listen, this is, we have learned the dispersion. Now some basics, listen. That is nothing but whenever, see, we can, whenever this rainbow we see it, okay, in the sky or on the screen, okay, anywhere, if you keep a screen here, you will get a rainbow color, but there will be no sharp boundary. Okay, there will be no sharp boundary between any of the colors. Most of the, all the colors are little overlapped. There is no sharp boundary. We cannot tell this is the complete red and this is complete orange. There will be a overlapping. Okay, there will be a overlapping. And prism is not producing any color. Keep this in mind. Prism is splitting the colors. That's it. It is not producing the colors. Then the width of each color, the width of each color is different. This you should know. Okay, assume this is red, this is completely red, okay, this is orange. So width of each color are not same, they are different. The reason you don't have to know the width of each color also, you don't have to know, because all these things are not mentioned in the textbook. It is not there in the syllabus. But one thing you should know, each color will have different width, thickness, okay, that you should know. Now we learn few more important points about prism and the splitting of light. See, dispersion, what do you mean by dispersion? Dispersion is splitting of light. Listen, understand carefully. Dispersion means splitting of light. Where it is happening? See, assume this is the first surface and this is the second surface. See, whenever the light is entering, that we considered as first surface. When the light is emerging, okay, that we considered as second surface. So dispersion only happens, see, dispersion only happens in first surface. Keep this in mind. Dispersion means what? Splitting of colors. That is happening here only, okay, at the first surface. Do you think dispersion happens here at the second surface also? No. So here the colors are already splitted, okay, those are already splitted, it cannot be splitted more. So dispersion means splitting of colors. That happens only at the first surface of the prism. That is very much important. Then refraction. Where is refraction happening? See, the light is entering here, there is a changing angle, right? So there is a refraction, one refraction as the first surface. Then here, when the same light, okay, now initially it is from air to glass, correct, air to glass. Now it is from inside glass to air. Again there is a change in angle, right? That means again there is one more refraction. So refraction happens at both the surfaces of the prism. Keep this in mind. Not only refraction, as well as the deviation. Deviation means change in angle. Whenever refraction happens, deviation also happens. So deviation and refraction both will happen at the first and second surface. Keep this in mind. First and second surface. So dispersion happens at only one surface. Keep this in mind. Okay, dispersion happens for only at the first surface, because it is nothing but splitting of colors. That will be already splitted at the first surface only. Again it will not get splitted. That is nothing but dispersion. Next, refraction and deviation occurs at both the surfaces. Because what do you mean by refraction? Change in angle. See, there is a change in angle. Again there is a change in angle two times at both the surfaces. Next, we which color is more deviated inside the prism. See, this is very much important. Inside the prism, which color is more deviated? See, whether it is inside the prism or outside the prism. Okay, violet is the most deviated color. Keep this in mind. In this way, they may twist the question: inside the prism or outside the prism. They mention whenever a white light is entering from air to glass, which color is deviated more? That is violet. From glass to air, which color is deviated more? Again violet. See what do you mean by deviation? Change in angle, which has taken huge turn, more turn. See, this is red, the first layer is red and the last one is violet, which has taken more turn. See, red is going like this almost. See, there is a change in small changing angle, but violet, there is a huge change in angle. So violet is the most deviated color, whether it is from air to glass or glass to air. In both the cases, violet is the most deviated color, red will be the least deviated color. So these are the things you should know. Okay, if you know these things, then aramse we can solve each and every theory question without any problem. So knowledge is important. Okay, if you have that knowledge, you can answer any question. And keep one thing in mind: they are not in the board exam, they are not going to take questions from the textbook. If you have the knowledge, you can answer all the questions. They are going to twist the questions. If you have the basic concept, okay, like assume there is a monochromatic light is incidented. Okay, monochromatic light is incidented. On which surface of the prism there will be a dispersion? If it is a monochromatic light, there will be no dispersion. Okay, these kind of hints you should have in brain. So monochromatic means single color. How can what is dispersion? Dispersion means splitting. How can a single color can be splitted? It is not possible. So monochromatic light dispersion is not possible, but refraction and deviation is possible. What is refraction and deviation? Change in angle. If it is single color also, there will be a change. There will be a refraction, right? If there is a refraction, there will definitely be a dispersion. So refraction and dispersion will be on the both side for monochromatic light also. But if it is a polychromatic, okay, then dispersion will happen only at the first surface, not at the second surface. These knowledge you should have, then we can aramse solve any question. So the theory solution video, you know where it is always in the description box. Not only this one, all the videos of all the chapter you can get it in the description box. So this chapter related videos immediately you will get it in the description box. Below that, in the same description box only, chapter wise playlist will be there. You can jump into any chapter anytime. Thank you.